All right, everybody. I want to give you a little help on, this is chapter 11, section 5, problem number 3B. 3B. You're using the same formula as you did on part A, except for now it's getting a little more complicated because they're asking us to find the rate, and that's embedded inside of a logarithm. I'm going to set this up pretty quickly. I'm not going to finish it for you, but you're still going to use the same formula. You know that the time is 6 hours. You know that time is 6 hours. So we're going to set this up saying we know that 6 is equal to, again, the log of the ratio, and it had to be the ratio of how much is still in your system and how much did you initially have in the system, divided by the log of 1 minus the rate. And we don't know the rate. That's our unknown. So this is how you're going to set it up. Now my suggestion is to make that into a fraction, the 6 into a fraction, and we're going to find our cross products. Our cross products have got to be equal if this is indeed a proportion. So we set that up. We end up with 6 times the log of 1 minus r has to equal 1 times the log of 5/20. Now instead of 5/20, I'm just going to say 0.25. It's the same thing. Now at this point, we divide both sides by 6. And you're like, well, why are we doing that? Because we want to get the logarithm that has the variable in it all by itself. We want to get that isolated. So we have log of 1 minus r equals, and if you plug this log of 0.25 and then you divide it by 6, you get the value negative 0.1003. Now at this point, you now have it written as a logarithmic equation. You can write this as an exponential equation. Remember, we have a base 10 that's implied right there. You can write this as an exponential equation, so you have 10 to a power of negative 0.1003 has to equal the 1 minus r. And now it becomes a pretty easy problem for you to crunch through your calculator and solve for the r.